In this video, we'll be learning how to find the surface area and volume of right circular cones. A circular cone, or cone, has a circular base and a vertex that is not in the same plane as the base. So here we have our base that's a circle and the vertex up here at the top. The altitude, or height, is the perpendicular distance between the vertex and the base. In a right cone, the height meets the base at its center, and the slant height is the distance between the vertex and a point on the circumference of the base. Note, the lengths of the radius, height, and slant height form a right triangle. Given any two of these three measurements, the Pythagorean theorem should be used to find the third. Now, let's talk about that Pythagorean theorem for a moment. We've already discussed that the height is represented by h, that the slant height is referred to as a lowercase cursive print L, and the radius is, of course, r. Now, for that right triangle, that would mean r squared plus h squared must equal L squared. In order to find the surface area and the volume of a cone, you'll need to have all three of these measurements, r, h, and L. Two of those will be given. You want to start by finding the third. Once you have that third value, then move into the surface area and the volume formulas. Speaking of our formulas, we have the two formulas. These are formulas that are already present on your formula sheet from class. The surface area of a cone is equal to the area of the base plus 1/2 times the perimeter of the base, which we typically refer to as a circumference, times the slant height L. The volume of the cone is equal to 1/3 times the area of the base times the height of the solid. Keeping in mind, one of them involves L, the other formula involves h, which means we need to have both. All right, so looking at our example down here at the bottom of our notes sheet, we have a cone with a radius of 20 units, a slant height L of 29 units, and our h value that we need for the volume is absent at the moment, so we start with the Pythagorean theorem. R squared plus h squared equals L squared. Substituting in our values, 20 squared plus h squared, which is our unknown, equals 29 squared. On to the calculator. 29 squared minus 20 squared tells us that h squared must be 441, which means h is the square root of 441. Now, if this number is a perfect square, then I want to simplify this square root and make it a whole number. So the square root of 441 in this case is 21. It happens to be a whole number. If it's not a whole number, leave it as the square root of whatever that number happens to be. Don't make it a decimal. This isn't your final answer, so don't round anything at this stage of the process. All right, so now that we have h, now we're ready to start actually working toward the surface area and the volume. As has been the case throughout this chapter, we start these problems by sketching the base and then finding its area and perimeter. In this case, our base is a circle. Ooh, this is not going to be good. You know how well I draw circles. That's not terrible. We have a circle with a radius of 20. We want to find its area, and we need to find its perimeter or circumference. So in this case, the area of a circle is pi times the radius squared. So the area of the base, in this case, capital B, will be pi times 20 squared. Keeping in mind, it's only the 20 that's squared. In this case, we take 20 times 20 and get 400 times pi. There again, pi is irrational. It's a decimal that's never going to end or repeat. So if I were to take 400 times pi in my calculator, it's going to give me a very long decimal. I don't want to round that because this isn't my final answer either. So I'm going to leave B as 400 pi. Now we find the capital P value, which is the circumference of a circle. And you may or may not recall that the circumference of a circle is equal to 2 times pi times the radius. So in this case, the perimeter of the base, 2 times pi times the radius, 20. Here again, I don't want to multiply by that pi because that's going to give me that decimal that I'm trying to avoid. Scoot this up a bit so you can see what I'm doing here. And we end up with the perimeter being 40 pi. So we have our capital B value and our capital P value, which are going to substitute for our surface area and for our volume formulas. All right, on to the surface area. The surface area is equal to the base area plus 1/2 times the perimeter of the base times the slant height L. Substituting our values, B is 400 pi plus 1/2 times P, 40 pi, times L, which is 29. Now at this point, you should be able to type that into your calculator and determine the decimal version of that particular quantity. Remember, throughout this chapter, we are using the pi key on the calculator, not 3.14, just to ensure that we all have the same solution. So, typing this in as it appears. 40 pi plus 1/2 times, or 400 pi, excuse me, times 1/2 plus 40 pi times 29 gives us 3,078.76. And our label is units, so units squared. That becomes our surface area. Now for the volume. Volume is 1/3 times the area of the base times the height. Volume in this case is 1/3 of 400 pi times the height of the solid, 21. So back to our handy dandy calculator, 1/3 times 400 pi times 21. 8,796.46, be cautious how you round, units cubed since it's a volume. And that completes how to find the surface area and the volume of a circular cone.